Okay, in this presentation we are going to look at variance ratios and the F distribution which we would use. So we have two variances here, sample variances, S1 squared and S2 squared, which is two samples S1 and S2. They are variances of independent random samples of size N1 equals 10, so that's the first sample size, and N2 equals 15, which is the second sample size. Now, just as a sort of quick remark, it's important to note that everything is sort of ordered here, so we have to sort of keep group with group, okay, or sample with sample, okay. Whoops, didn't mean to do that. Anyway, so sample size N2 equals 15 from normal populations with equal variance. Okay, so what we have to do here is find the probability of S1 squared over S2 squared is less than 4.03. Now, this is essentially what we'll call the variance ratio. Actually, I have it written there. So that's variance ratio. Okay. Now, it's very important to actually sort of keep consistent between what is the numerator and what is the denominator. Okay. Now, not for any particular reason, we'll go for S1 squared, the first sample, as the sample that corresponds to the numerator. Okay. And so the variance there is S1 squared and S2 squared for the second sample, which is in the denominator. Now, the important thing here is the degrees of freedom, okay? So I actually have that messed up there, so that should be N2 minus 1, okay? I'll just write it again here, N2 minus 1, okay? That's the degrees of freedom for the second sample. Now, the thing is, they always have to sort of stay in that order, okay? So that's the important thing here. So the first degrees of freedom will always correspond to the numerator, and the second degrees of freedom will always correspond to the denominator. And if you switch the order of what's on the denominator and what's on the numerator, you have to switch the degrees of freedom as well. That's the important thing. Okay, that's really the gist of this video, really. That's what the important thing about this video. Now, what we're going to do here is we could use statistical tables, okay, and I'll probably look at that in a different video. But in this instance, what we'll do is we'll look at the R programming language, okay? So this is for you finding out, it's for helping you check your answers, basically, okay? So the probability, PF, is the R command for finding out the probability of F being less than 4.03, okay? So that's that command there. And what we also have to do is put in degrees of freedom, okay? Now, sorry, actually, I'm jumping ahead there. The variance ratio is S1 squared over S2 squared, okay? And that is an F random variable, F distributed random variable with N1 minus 1, N2 minus 1 degrees of freedom. So essentially, it's an F distributed variable. So that's where we're getting here with this F, okay? We're dealing with the F distributions, okay? So PF is the command we're going to use, okay? That's our quantile, 4.03, and again, our degrees of freedom. Now, if you get a little bit better at R, you'll find that you don't have to put in Q equals and DF1 equals and DF2 equals, okay? But the important thing here is just what are the degrees of freedom, and again, it's 10 minus 1 and 15 minus 1, okay? And they do have to go in that order. You can't swap them around. You can't go 14 and 9 and expect the same answer. It's wrong if you go 14 and 9. Now, the answer turns out to be, the answer to this question turns out to be 0.99, okay? If you were to round that to 2 decimal places, okay? Now, so that's the probability of the variance ratio is less than 4.03. That is probability of F being less than or equal to 4.03. Now, really, it doesn't really matter too much. I suppose I should stay consistent. Okay, F being less than 0.403. Okay, this actually is probably what you would see in the tables. Okay, if you're using the tables, you probably use this approach and get the upper tail distribution, upper tail probability. But we won't really need that in this instance, but that might be the approach you might take in if you're using statistical tables, printed tables. But anyway, our answer there is 0.99, okay? Now, just actually sort of, if you were looking at tables, you probably would go, you just have to check which column you're on, okay? So it'll probably be df1 on the column. So you go down to column 9, df2 along df1 along the rows and df2 along the columns. So you just probably have to sort of figure out what your number would be there. Okay, you probably will get 0.01 as your alpha value there, and 4.03 on in the cell in the tables. Okay, that's why it's a sort of trickier approach. You getting the hang of the tables requires a good bit of practice. Okay, what you would see there is you see 4.03 and you think, oh, that corresponds to an alpha of 0.01. That means my answer I'm looking for is 0.99. Okay, that's the idea behind this row, this sentence here, this clause. Okay, but really, it'll be really handy to be able to learn a little bit about R and be able to check your answers, because I appreciate that working with tables, particularly for the F distribution, can be a little bit tricky. So if you get good at R, that you can check your answers, which would help you a lot. Okay, so that's the R programming language. Okay, we'll leave it there.